Hi everyone! Who didn't see the previous video where I bought 5 non-working motherboards on eBay? Here I will put the link. So this is motherboard number 1 from the batch. This is model MSI MPG X570 Gaming Edge Wi-Fi. So from the words of the seller, this motherboard powers on but failed to boot. During testing, the motherboard debug CPU light is always on. This repair is going to be an interesting one, so stick around until the end. So let's start from the resistance measurements. As usual, we will use the ATX24 pin connector. Here we place the ground. Let's see, from 3.3 volts, and we have no short. It's 900 ohms, 5 volts, kilo ohms, no short, 12 volts, kilo ohms as well, 5 volts standby, 5 USB, at 800 ohms, minus 12 should be no short, and shows mega ohms here. The CPU is mega ohms, and what do we have? We have coils over here. And what we can check is this coil probably is a memory one. It's 2.5 volts, but I can be mistaken. It's 1.3 kilo ohms. Right here, another coil. Okay, it's 700 ohms. It's normal. What else? Here is the CPU coil. This is probably SoC or something like that. It's 2.9 kilo ohms. So everything looks good. Let's check the V core, since the coils here are closed, so we can check it on the back of the board. We'll have ground here, and we have kilo ohms for the V core. And I believe this one is going to be SoC. Okay, 16 kilo ohms. This is nice. So this board is safe to power on, and let's try to power it on and see what is going on with it. Now looks everything okay, except that you should see the readings of the lab bench power supply. So power it on, and in standby mode it's 100 milliamps, which is healthy for these boards. And let's press the power button. We have a reaction. It's 2 amps, and unfortunately 25 watts, 2 amps, 2.1 amps, and steady. So we will not go anywhere. The CPU light on. It looks to me like it could be a BIOS problem, but we'll definitely, let's try to clear the CMOS. I couldn't find a CMOS pins to short. However, what I can do is to remove the battery and to short the battery, plus and minus, with my metallic tweezers, and it's gonna reset the BIOS. Okay. Plug it in the battery. By the way, what about the battery? Like, do we have a voltage on it or no? Let's see. Oh. And we have 2 volts on the battery. It's good. Okay. So let's try to power it on again. Pressing the power button. And I guess no changes. The same as was described. Let's remove the heatsinks. let's check with the microscope. So the first as there's the signs of the opening with some tool, but there's no signs of damage here. The GPU goes straight over here, and I don't see any damage in this area as well. Okay. What about the CPU? Looks fine to me. Okay, let's go to the back of the board. And on the back, what do we have here? What else do we have? Those are the MOSFET drivers for the VRM. And they look fine. Here we have an area with the elements. Under the PCH. Microscope inspection showed no knocked off components, no burn marks, so I pulled up the board view to figure out why the CPU wasn't initializing. I had some time to go through the board view and found a few interesting spots that worth checking on this board. So first of all, I want to measure whether we have V-core and whether all the other voltages are present and correct, including the voltages for the PCH. Once we confirm that, we'll move on to the power good signals and trace from there. Since there are no exposed coil pins here, I can measure V-core the usual way. Instead, I'll use those unpopulated capacitor pads. They should give us the same reading. I'm powering up the board. We have a steady 25 watts of consumption, which looks about right for this stage. Now let me check the voltage here at this capacitor pads. And we have 1.1 volts. Well, showing as minus 1.1, but that's just wrong polarity on my probe. If I flip it, yes, 1.1 volts. V-core is present and in the expected range, so that rail is good. Okay, here we should have 1.2 volts, and we have it. Moving over here, that's the PCH power rail sitting at 1 volt. Same story for the CPU rail. 0.92 volts, which is normal. And right here, 2.5 volts for the memory. Now this one I expect to be 1.8. Let me get my probe on the correct side. The CPU is getting warm, which tells me it's actually doing something. Let's me power cycle and run it again. So all the main voltages are present and accounted for. Alright, so there is an interesting area here, right near the PCH slot. Let me show you what I mean. So, this is the all power goods circuit for the S0 state. Its job is to generate one final power good signal that tells the CPU everything is up and stable. 5 power good signals from different circuits come in through these small diodes, and they work like an AND gate. If any of them is low, the final signal goes low as well. Let's get under the microscope. So, the power good signal, all power good signal, should be right here. And we need to start the board, starting the board, and as you see, so we have 3.3 volts, which means the power delivery on this board is totally fine. The next, what we want to do is to check the BIOS. I want to mention right away that before going to the programmer in this video, I tried reflashing the BIOS with the M-Flash button a couple of times, but all attempts failed. The flashing LED would blink for a moment and then just go steady. On On AMD X570, the CPU reads the BIOS flash directly from the SPI. It's part of its own initialization before the system ever gets to DRAM training or boot device detection. So the LED sequence reflects what stage failed, like CPU, so then the CPU didn't finish the initialization, and we should look to the BIOS. So instead of going through all of the sequence for posting of this motherboard, we will start from the end, and we will try to see, do we have any BIOS reading? Does the CPU attempt to read the BIOS or no? So we can do it within the oscilloscope. The CPU should send, I don't remember, low or high packet to the BIOS chip, and BIOS chip should answer with its own JTAG ID, which identifies the BIOS chip manufacturer. So let's try to do it. You can see the oscilloscope feed on the top left screen. Let's power on and see if we're getting any packets going to the BIOS or not. We have a data in pin number 2 for the BIOS, which is this pin. Power on in standby, pressing the power button, pressed. And here we go. So we have a request from the CPU to the BIOS, 77 microseconds, right? I'm not sure if you see it here or no. I guess no. Yeah, here we go. It's 77 microseconds. So what we know now is that the CPU is requesting the BIOS. Whether the BIOS is answering, that's still the question. But the fact that we have this request is actually significant. SPI communication with the BIOS is one of the last things the CPU does during initialization, which means almost the entire boot sequence has completed successfully up to this point. Let's see if we have any answer from the BIOS to the CPU. And this is going to be a pin number 5 right here. Alright, let me set up the oscilloscope. I'll configure it for a normal trigger on a rising edge. Powering on and pressing the power button. And as you can see right here, we have a successful response from the BIOS. Typically, you'd expect 6 or 7 high packets containing the JTAG ID. And that's exactly what we're seeing. So the BIOS chip itself is alive and responding correctly. That also the issue is most likely with the firmware rather than the chip itself, which means our next step is pretty clear. We need to reflash the BIOS with a fresh firmware image and see if that brings this board back. Pressing power button. We have 32 amps. It looks promising. Let's wait until the motherboard will reflash all internal controllers. Usually the board restarted several times within this process. Okay, it's still something going on. 36, 39, 40. Okay. It's completely normal after BIOS update or CMOS reset. Whoa, AC spikes to 62 watts. Let's try to connect HDMI cable on the fly. It could work. So small probability, but anyway, let's try. That's connected. Let me also show my capture card to finally see the desired BIOS screen. Not now. Okay, we'll power off. The CPU is quite hot already, so we need our heatsink. The motherboard has already flashed all the controllers in flash chip, so let's power it again. Let's try to power it on again. Pressing the power button. We have right here the pause screen. Will we have a BIOS? Finally, we have a BIOS screen. The long repair wait can be substituted with a simple BIOS reflashing. Wow! Here we have the latest stable BIOS release from 2025 for this board. Do you remember how I said on the beginning of this video that it looks like we have a BIOS problem? I was right, and many of you will say the repair could have been much faster, and I agree. It could have been. But that's how repair work goes sometimes. So this was the second board from those 5 eBay boards. This one didn't give us much real repair content beyond BIOS flashing with the programmer. My guess is the seller couldn't flash it themselves. We already saw that the onboard flash button didn't work. This is a pretty common scenario where someone interrupts a firmware update halfway through, breaks the board, and ends up listed for parts. This video ended up being more teaching than repairing. If you like this one, hit the like and subscribe buttons. Only about 15% of you actually subscribed, and it really does help the channel grow. Leave a comment below, I try to answer all of them, and thanks for all the kind words and likes, it genuinely keeps me going. And yeah, you can always find a list of the hardware used for repairs in the video description. See you in the next one.